Can you hear me? Wow. Awesome. Cool. Thank you for having me. Thank you to the organizers of this event, which is awesome. Thanks, Robin, for setting everything up. It's awesome to be back and see so many familiar faces from Reject last year, which is awesome. It's a total coincidence. I'm actually staying across the street. I can actually see that red tent from my bedroom. So don't stalk me or anything. But anyway, my name is Jed Schmidt. But before you get any ideas about my locality or German language skills, why don't you just think of me as Jed Smith? I'm originally from New York. I was first in Germany to present at JSConf EU in 2010 about Fab, which was a crazy thing that I hacked together that was like a new approach on functional programming that turned out to be like a very good academic exercise and very little more, but it was very satisfying. Last year I was here for 140 Bytes, which a lot of participants from Germany, from Berlin, from Hamburg helped me on that, which was awesome. Since then, not here, but I did Ramadan. Which you might know me from Ramadan, maybe you know if you guys are a fan of ramen. I ate ramen every night for 30 days and made a Twitter app on Node where you could tweet a picture of your ramen and we would figure out what time it is to make sure you're observing Ramadan. The idea is it was Ramadan for ramen, where you can eat anything during the day, but after sunset you have to eat ramen once. And so I built that using Node. But I know what you're wondering. So I'm already, like a good few minutes into the presentation, and there's no hot chick slide, so that's really just a chick. That's a hot chick. Sorry. Anyway, so I didn't really finish my slides, to be honest, which is kind of embarrassing. But let me tell you why. Because like any self-respecting geek, I totally geeked out on the meta process of making slides. And so I'm actually dog-fooding my own slide-making slideshow thing for this presentation. It's called WeNote. It's like Keynote, but more we. And for more information, you can go to my GitHub. But basically what it does is it takes all of the child nodes of the body element in an HTML document, and it blows them up until they fit in the window, and it just goes left and right, and you can just go through your slides. So it's a very lightweight alternative to something like Reveal.js. Anyway, so I have kind of a crazy idea that I want to show you guys and share with you guys and get your feedback. In terms of craziness / usefulness, I want you guys to help me gauge where it is. From 1 to 10, where 10 is Substack. So you guys are going to help me calibrate this. But I want to start by rewinding to where this all started. A long time ago, like 2 months, I had an idea after doing some web development. And it happened on August 2nd, 2012, or as you guys know it, February 8th, 2012. And I tweeted this, wondering if this exists, a Node.js server that exposes WebSocket-connected browsers over subdomains as disposable webhook-ready endpoints, which is like the douchiest, buzzword-laden tweet ever. I mean, really, yeah, kind of proud of that. I only missed real-time and transpile, but that would have totally nailed it. But yeah, so I had this idea. Well, why don't we build applications this way? And I then started thinking about it, and the logical extreme conclusion of this was something called Browserver. Browserver is a Node.js server in your browser. Okay? Browser, server, browser, server, browser, server, Browserver. Okay? All right. Does anyone know what this slide represents? This slide represents where I would have put a yo dog joke. So I didn't. Sorry, Paul Campbell. Anyway, so this code should be familiar to all of you. It's basically the upper line is basically the hello world of Node. The bottom is HTTP client. So the top one, binds to a port, creates a server. You can receive HTTP requests inbound. The bottom one is going out and getting a URL and coming back, right? This code by itself is not remarkable until you add another 17 characters. These. So basically what I've done is I've recreated the HTTP module that's in Node in the browser. So you can have documents where you're actually spinning up web servers in your browser, right? So, WTF, as you would say in Germany, what the Frühstück? I think there's like enough letters that it matches. Somewhere there's a few extra ones, but as they would say in Sri Lankan, Sinhala punctuation kundalia, which is actually just shorthand for Unicode code point 0DF4, also known as the brow, which is the mascot of Browserver. Sorry, that was a little bit long. Anyway, so that is the brow. Browserver is HTTP over WebSockets, okay? So basically, here's how it works. 5 easy steps. Ready? Step 1. The browser connects to the server using a WebSocket, okay? This is vanilla stuff that you've seen before. You can use Engine.io if you want. You can use Socket.io. You can use Sock.js. You can use whatever, vanilla WebSockets, whatever. The browser connects to the server. Step 2, the server assigns and announces a host name for that browser. So for example, on browserver.org, you can go there and you will get a host name, and that'll be like some random ID .browserver.org, right? It's just a subdomain, right? And so then what that means is the server will proxy HTTP in. So any requests that you send to that host, the server will actually proxy them and send them directly over a WebSocket to the browser, and the browser will then have an HTTP request, the same API that you would see in Node. Likewise, the server proxies HTTP out. So the browser can send HTTP requests, over this through the same Node API, and send it to the server, and then the server will just proxy that out to the internet. So instead of having, you don't have to worry about cross-domain stuff, right? You can just send it anywhere because the server's doing it for you. So it's just a really kind of transparent way of doing that. So basically, the browser becomes a server. And so I have a site that kind of shows you all this. I'm actually going to close this and reopen it. Get there, network. Please, don't embarrass me. Oh, man, it's slow. This reminds me of when I gave a presentation in Australia a few months ago. Wow, really? So what you would see in a non-saturated environment is the website. And let's see if it actually will know. No? Would it help if I got on another endpoint thing that wasn't, like, are they all the same, 1 through 5? Monday 45? Wow. Oh, man, really? That was like my whole presentation. All right. We'll let that spin for a little while and see if he comes back. Bye. All right. So basically what it does is it exposes, because you have now an HTTP server in your browser, instead of having the browser initiate all of the action, anything on the internet can initiate action on the browser. For example, here's like just some use cases that you can see if you go there. Here's an example. I want to find out the location of that browser. So I literally send an HTTP GET request from my terminal to that browser's host. And what happens is I actually use the geolocation API in that browser to fetch that location. And I return those coordinates to the person that originated that request. So it's really cool because what happens is, you go, and then all of a sudden, so like you're in your terminal, and you get, location, and then all of a sudden in your browser pops up a dialog box that says like, blah, 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 wants to know your location, allow and deny, and you click allow, and then meanwhile in your terminal, your geo-coordinates are actually sent back. So it's actually kind of cool. You can also ask questions and, oh, really? You're not gonna you're not gonna jank all my stuff. Oh, hey, no, actually, but just being near me, yeah, thank you. The power of Felix. Here's the Browserver website. So the idea is like, hey, I upgraded your browser to web server. True story, here's the last request that came in. And actually, you'll see this change if you guys connect to Browserver right now. You'll see this actually change. It's actually just the last HTTP request that came into your browser. It displays that. Someone just left. Whoa, bye, guys. Oh, back. Anyway, so you can actually see those domains. And so here's the response to your browser served, no content. This is because this is the endpoint of server count. So anytime a new server comes online, a new browser, I just send a put to all of the connected hosts telling what the current server count is. That's kind of cool. And so there's your browser responded. So this is the host that now my browser has, right? So this is literally accessible on the internet. And if you send something here, it'll just get proxied directly into my browser. So here's some examples. Everyone loves QR codes. I'm not even sure this is going to work. Can someone QR code that? Technology. See if this works. Okay, where are we? Where's my QR code? Deep nested in my folder somewhere. Here we go. Oh, sweet. Browserver wants to know your computer's location. Cool. Allow. And so what you can see now is that I actually have on my phone, oops, now Google wants to know my phone's location. This is getting kind of complicated. It actually just shows a Google map of my current location that was actually taken from the browser. That was pretty cool. Here's another question. Another thing you can do. There we are. Scan again. Get this. Hey, guy. Sorry. Did I get it? Okay. What is your name? Oh, that's cool. So my name is Jed. Enter. Oh, multiple people are hitting it. You guys! Anyway, so you really can't see it because it's tiny, but my phone now says Jed because it just returned that response, right? So the idea is instead of having the server have all this marshalling logic of like what goes where, just you push all of the logic in your application out to the clients and just treat your clients as just another server so that basically you're speaking HTTP everywhere. So specifically, here's how it works. There are two parts. The first one is Browserver node. It's tiny, right? And it looks like this. Get your HTTP server, get your WebSocket server. In this case, I'm using Engine.io as a polyfill, which is just like Socket.io, but not all that fluff on top. It's just literally just basically a multi-transport WebSocket implementation that falls back to other things. And then Browserver. What happens is I create an HTTP server just like usual. I create a WebSocket server, and I create a Browserver. The Browserver listens to the WebSocket server, and it also listens to the HTTP server because it's proxying like this, right? These two, right? I see. No, it's funny, guys. Funny. And then finally, the Browserver emits a connection every time someone connects. That server object that you see in that function is basically going to have a host name, and that host name then is just an accessible host on the internet. So then the HTTP server listens on 80, and then that is your Browserver. That's all the code you need, and then all of the magic you would do is the connection. So for example, maybe you want to announce, like for example in the app you just saw, when a connection happens, it announces it to all the other clients so that you can see how many clients there are. Meanwhile, the browser part of Browserver is also on GitHub. It's a client. It's tiny. It's 1.31 kilobytes, minified, mini zipped or whatever, and it looks like this. You put your WebSocket shim. This is optional. I'm using Engine.io, so just put that in there. Then I put Browserver, which has that very small code you just saw. Then the meat of your application. First, create a WebSocket. How do you even have this open still? Oh, is it the same guy? I will find you. And just like Node, it creates a global object called HTTP, and you create a server, and you take a request and response, and then you listen to that WebSocket. That WebSocket is your connection back to the Browserver proxy that basically is your kind of host, your proxy host on the internet. And you can actually create many of these servers as you want, connecting different places. And so it does this using WebSockets. But it could use anything. It could use server-side events. It could use WebRTC. It could use polling. It could use polling, which you know is long polling. Really? No. But at the end of the day, the most important thing is at the end of the day, it's HTTP, right? So it's HTTP. Why would you use HTTP? Well, there's a few reasons. Why would you use JavaScript? So like, who uses JavaScript for code reuse? Not a lot of people. Right? It's actually not that helpful, I think. For me, the big asset of JavaScript is overhead. Having the same language. You're always dealing in the same language. I feel like I'm just more prolific if I can always deal with one language. Just because the phase change of one to the other is not that severe. So that's why I kind of like it. Another reason is, why do you use HTTP? Well, why do you use Node? Right? Well, you use Node because it has callbacks, basically. I mean, that might be a little bit generous, but I'm pretty sure it's true. Callbacks are the best / worst / best again thing about Node. So like callbacks are kind of great. Like you don't have to use callbacks. You can build abstractions on top of callbacks. And like really early in Node, we had promises, and we're like, dude, screw that. Like we're going to build building blocks on top of callbacks, but callbacks will be like the de facto, like the lowest level thing you can do to do asynchronous stuff. And then on top of that, you can build events and you can build streams. HTTP has a concept of a callback too. What is it? So like, for example, if you program in like old school JavaScript that's like synchronous, you would call a function and it would return a value. Just like HTTP, you make a request and it returns a response, right? So what's the HTTP equivalent of a callback where I give it to you and like I go away and you just have a little like function reference that points to somewhere in memory where when you call that thing, it'll execute some code somewhere and get back to me. What is the HTTP like equivalent of that? No. No? Anyone? Really? It's a webhook. Does that make sense? Yes, webhook, yes. Yes, the WeBooks. Sounds like a German startup. Yes, thank you. WeBooks. I'm not going to get an inspector and fix that. I'll fix it later. But yeah, it's a webhook. So basically, the idea is with a webhook is just like in Node or in JavaScript, you'd have thing fetch, have a callback. It's thing fetch, but the callback is a URL. So when you have this information, just post it to this URL. And so this is a common paradigm in all sorts of real-time APIs. Facebook uses it. Twilio uses it. Like all these people use callbacks. Instagram uses it. And you get a callback. You get an HTTP post every time something happens, right? And so that is I really am kind of surprised. To me, WeBooks are the best idea we're not using enough of. I would love to see more of webhooks, and I think the idea is by unifying on something like HTTP, we can bring more power to webhooks because the consumers of webhooks are no longer just servers, but they're browsers too, so you can have a more kind of like level playing field ecosystem. Webhooks can help you abstract transports. So instead of having to worry about like what transport you're using in terms of RTC or server-side events or WebSockets, if you just abstract it as treat your browser as just another server, it kind of simplifies the cognitive overload because you're always dealing with HTTP, whether it's going inbound or outbound from your node process. Also, it's cool because you can decouple services. You can put, now that these guys have their own host on the internet, you can just put all of your real-time stuff on one server, and it just exposes this ever-changing list of hosts, and those hosts are accessible or not accessible. And so it's a really good way to not have the WebSocket part running in the same process because it's going to be HTTP anyway. And it's cool because you get to use the tech you already know, which is if you're using Node, you're using HTTP. It's just like JavaScript. You just have the same kind of model that you're always operating with. And that's about it. So if you guys have any questions or comments, I would love to hear about this. Otherwise, thank you very much. Yes.
Actually had used this for something besides this presentation.
I have not. This is like kind of like Fab was. It's like an exploratory idea. Like, wouldn't it be cool if we did something like this? The thing is, I only started programming up for a living this year. Until January, I was a full-time freelance Japanese translator. And so doing stuff where it's like production, where I'm actually like spinning up servers is like a new thing for me. So this is kind of the style of what if we did this. I think it's kind of cool. A lot of the thing is there's actually services that do this where you can kind of outsource your real time. There's Pusher, there's Simperium, there's all these things. The thing is none of them are quite the same. Like the way that Pusher works is it's one way. Like your client just gets events. Like you can't actually respond to that, and you can't make outgoing events to Pusher. So you're like Pusher's only like one half. Then you still have to use XHR for other things. But as we have more real-time stuff, I think we really need to figure out like a more common thing. Like we kind of unified on REST and we kind of unified on JSON for a lot of things. But I feel like because real-time is newer, we still don't have a common paradigm that we default to for the apps that we build. So does that answer your question?
Any more questions?
Sweet. Thank you guys.